Hey everybody, today we got integer exponents, which means probably going to see a lot of negative exponents. Put a few little scribbles here on the title page, let you kind of look forward to what you're about to see. I know that makes you excited, but that's where we're going. A lot of negative exponents today. Few rules you need to know. First rule, I hope you remember these from algebra, but who knows. Anything to the zero power is 1. Underneath there, I wrote, what is 6 to the zero power then? 6 to the zero power is 1. A couple reasons for this, and I will share those with you in class tomorrow, why that is true. It's really kind of interesting. Second rule, if you do have an integer exponent, you got a negative exponent like this one, all that does, I always use a term loosely here, it flips your term. So a to the negative m is really 1 over a to the m power. That's what makes the exponent negative, is when you take it to the other part of the fraction. If it's on the top, you take it to the bottom. On the bottom, you take it to the top. So I have here 4 to the negative 2 power. That would actually be this, 1 over 4 squared. And I think you know what 4 squared is. I hope you do. It's 16. And you just get 1/16. And the third rule here on this slide, really the same rule. What if you have a fraction and you have negative exponents in your fractions? Well, like I said earlier, to make them positive, you just put them in the different part of the fraction. This a is in the numerator, b is the denominator. Well, when you take care of the negatives, what happens is they just flip. B to the m, a to the m. On the example right here, the x to the negative 3 would need to go to the denominator. The y to the negative 8 would have to come up to the numerator. And there you go. All there is to it. So those 3 rules are very important for integer exponents. Now the bad news is there's 1, 2, 3, 4, 5 or 6 more rules with exponents, and I will give you some great gestures for these tomorrow. I'm just going to talk through them real quick right here, but I promise you in class tomorrow I'll give you some gestures. They'll make more sense tomorrow, and you may even know them anyway. When you multiply the same base, you add the exponents. So when you multiply, you add exponents, which means the quotient rule, when you divide the same base, so you have to have the same base here, you subtract exponents. When you multiply, you add. When you divide, you subtract. If you have one exponent raised to another one, that's when you multiply the exponents. If you see this right here, a to the m is being raised to the n power. So you have one exponent being raised to another. That's when you multiply the exponents, the only time. This is called raising a product to a power. I like to say if there's an exponent outside of parentheses, it goes for everything inside, which is what that says. It goes for the a and the b inside the parentheses. And the same thing here, if you raise a quotient to a power, if you have a fraction raised to a power, you raise the numerator and the denominator to that same power. And like I said, I know you're excited, but I'll give you some gestures tomorrow that will help you with these, help you remember them a little bit better. But all of them very important. Okay, I want to show you 5 quick examples here, and we'll finish up the video. The first one is the multiplication rule. If you look at part A right here, part A has y to the negative 5 times y to the negative 3, which means you're going to add the exponents. If you add negative 5 and 3, you get y to the negative 2. Now, one rule for us today, you are not allowed to leave a negative exponent in an answer. So remember what a negative exponent does. It flips the term, 1 over y squared. Let's go to part B. Part B, it has coefficients of 48 and 16. Remember, fraction bar means divide. So if I divide 48 by 16, I get 3. And if I subtract the exponents, 12 minus 4 is 8. So I'm just going to put x to the 8th. And the reason I don't have a fraction anymore is because my bigger exponent's on the top. When you divide your exponents, we're going to keep the base wherever your larger exponent was. And we'll work on that tomorrow also. Part C has a power to a power rule. Negative 3, that's when you multiply your exponents, when you raise a power to another power. Negative 3 times 5 is negative 15. Remember, do not stop there. Do not leave a negative exponent in your answer. Go ahead and flip that term. 1 over t to the 15th power. Part D is the other rule where you have the 5 outside parentheses, which means it goes for everything inside. So I would do this. I would do 2 to the 5th power and s to the negative 10 power. Now, this is interesting. 2 to the 5th is 32. We'll go ahead and change that. S to the negative 10 is going to get flipped because it's negative. Now, the negative doesn't go for the 2. It just goes for the s. So the s goes to the denominator. The 2 does not. That's part D. And the last one here on the slide, end of the day on the video, is part E. And E, I'm going to go ahead. What I like to do first is work inside as much as I can. So I'm going to go ahead and divide that 45 divided by 9, which is 5. And I have x negative 4, y squared, z negative 8. and I have this negative 3. Now, what I would do normally is I would have gone ahead and flipped the x and the z. But what I notice is outside there's also a negative exponent. And because there's a negative exponent outside, that's going to change the sign, because remember that exponent outside goes for everything inside. So I get this. I get 5 to the negative 3, x to the 12. Remember, we're multiplying exponents because it's a power to a power. Y to the negative 6. I'm having a hard time with the numbers. Z to the 24. Now I'm going to simplify anything that needs simplified. The 5 has got to go to the bottom. And because it's 5 negative 3, I'm going to go ahead and do the third power, make it 125. Also, the y has a negative 6. The y is going to go to the denominator. The z is going to stay because it's positive. And on the numerator, the x is going to stay because it's positive. So a couple of steps here. And that's not the only order you could have gone with that one. You could have flipped some things earlier. Not a lot of rules as far as when things go. But one thing I need to express, make this very clear, you can only flip-flop things like this when they're all factors, meaning they're all multiplied together. If they are added, if there's addition or subtraction involved, it makes things a lot messier. But today, that's all we're going to be, tomorrow, it's all going to be working on is the multiplication as factors. So hope that helps. We'll give you some gestures tomorrow and also work on the assignment. And make sure you have some notes with you. So see you then.